Okay, so today's lesson is about real numbers and the number line. So we're going to talk about real numbers in detail, see what they mean, and what groups of numbers belong to the set of real numbers. And then we're going to put them on a number line and learn a couple of properties about real numbers. Those properties are the additive inverse and the absolute value property of real numbers. Okay, we're going to start by defining the real numbers. So basically, real number is any number you can think of in any form or sign. For instance, you may say 2, -3, you may think of 1.5 or 1/2, which is a fraction. You might think of, let's say, maybe radical 2 and any other type of number, maybe the letter pi, the number pi, which is equal to 3.14 and some other change, or even something like 3 to the second, an exponential expression, an exponential number like this. So all these numbers are called real numbers, all of these real numbers, but they have some subgroups or subcategories that we're gonna they belong to. For example, real numbers. We call this a real number set. All these belong to the real numbers. And real numbers itself can be divided in smaller groups. The first one is what we call the natural numbers. Natural numbers they start from 1 and go up. They don't have any negatives or decimals, not even 0. They don't have 0. Those are not real numbers. After this, we have another group called the whole numbers. Whole numbers are pretty much these, but we add 0 to them. So we add 0 to this group, and it turns into a new group or a subgroup of real numbers that we call the whole numbers. And what else is missing from here? So far we have 0 and 1 and positive numbers. What do you think is still missing from these numbers here? What type of numbers? And so as we go, the group or the sets grow. Set of real number grows with more numbers. So far we have these. The next one, we're still missing the decimals. I mean the negatives, and then the decimals, then the radicals or decimals like these. So the next group is called the integers. Integers basically include all this and the negatives. So we have 0, 1, 2, 3, basically all this in addition to the negatives on the other side. Okay, so we have 4 here. And these numbers get smaller and smaller. This is what we call integers. 0, the positives, and the negatives. No decimals yet. The next group is the group of, so now we're going to include the decimals and fractions, which are pretty much the same, because when you divide a fraction, you get a decimal. So that group is called the rational numbers. Okay, rational numbers. That includes pretty much all this. Okay, all the above. All the above plus decimals and fractions. Fractions, for example, the ones we wrote earlier. For example, this is a fraction, decimal here, 1.5, or it could be a fraction, 1/2, which is technically a decimal. What's the decimal of 1/2?
0.5.
That's right. It's the same number, different forms. Or maybe 1/3. I believe we did this when we did the division of numbers in the second or third class. What is 1/3 equal to as a decimal?
3.
0.3. And does it stop?
No, 0.3 and then 3 continuing, correct?
That's right. So it never stops. It's a repeating decimal. So it could be an ending decimal or repeating decimal. So that's what rational numbers are. Repeating, so ending, or okay, so that's basically what rational numbers are. When the decimal ends, for example, when you divide something, you get exactly 1.5 or 1.38, exactly that without other decimals. So that's ending, or repeating in a pattern like this. So that, or maybe let's say 1.28, for example, and then have another 28 and another 28, and it never ends. So we have a pattern here, even though it repeats, but repeating a pattern. So that's called rational. And the opposite of this, when it's not, the decimal doesn't end, it doesn't repeat. So it doesn't end and it does not repeat, meaning just random digits after the decimal. No end, no pattern, just random numbers. That's basically the opposite of rational. What is the word? What is the opposite of rational? Rational, the opposite of it would be? That would be irrational. So basically the opposite of this. So non-ending, ending, and non-ending, non-repeating decimals. Okay, a number can only be either rational or irrational. It cannot be both because these are opposites. Let's take the example of pi. So pi, as you know, is a famous number, which is equal to 3.14. But not only that, it actually has a non-ending decimal, and the numbers just keep repeating in no pattern, just random number generating. That's why it's an irrational number. There are literally billions of decimals to this number, and they never end. Some of the digits are 15, 92, and 65, 35. As you can see, there is no pattern here. 14, 15, 92, 65. So that's an irrational number. Same thing with radical 2. If you take a radical 2, it's 1.40 something. If you plug this in a calculator, I'll give you the sum of the digits. Same thing, the digits never end, and they don't have a pattern in which they repeat. Let me give you the first 5 or 6 digits. So 2 square root. So it's 1, 41, 42, 13, 5, 6, and so on. Non-ending, non-repeating decimals. So that's what irrational numbers are. Same thing with radical 3, radical 7. Unlike radical, for example, radical 9, square root of 9 is 3. So that would be a natural number or a whole number, also an integer. Okay, so that's basically what we mean by real numbers. All these types of numbers, they all belong to the same group, which is the set of real numbers. There's another group that has all this and more numbers. It's called the complex numbers, but it's not the subject of our discussion in this class. That's for a different class. It involves more numbers and more properties. So the whole class, this algebra class will be about real numbers, and any of these forms here, decimals, negatives, fractions, and so on. The second thing I talked about now is the number line. So the number line, as the name implies, is basically just a line with numbers on it. For instance, it's a straight vertical line with a 0 in the middle. It's like a ruler, and we just have numbers on it. You have 1, 2, 3, 4, 5. The numbers keep going up. What's on the left side of 0? What types of numbers? What type of numbers? Everybody, what do you find to the left of 0?
You said what's on the other side of 0?
Yes, to the left.
That's -1, right?
-1, and then it keeps going. Okay, so -2, -3, -4, and so on. So that's what we mean by the number line. And we can put all these numbers we mentioned earlier, we can put them on the number line. We can plot them and find any number, any real number basically can be put on this number line. So let's start with the sum of those numbers. The first one, of course, let's say 2. Of course, is a positive number. It's over here. Then we have -3. -3 is right over here. Easy to spot because it's negative. Then we have 1.5. So where would you put 1.5 on this number line? Between what numbers?
Wait, what was the question? You said where would we put 5?
1.5, the decimal. Where exactly do we find this on the number line?
Between 1 and 2.
Between
Exactly. 1 and 2. It's 1.5. So we can do like this. So 1.5. And the next number is 1/2. Where would you find 1/2? So 1/2 again is 0.5. Where exactly would that be on this number line? 0.5. Between 0 and 1. Right? 0 in the middle, that's right, is 1/2, which is 0.5. And radical 4, or radical 2 rather, is here, 1.41. So 1.41 would be between 1 and 2. But closer to which number is it? Closer to the 1 or to the 2? 1.41. So it's 1.4, it's less than 1/2, less than 1.5. It's going to be somewhere here, right before 1.5, because 1.5 is higher. 1.4 right before that, so radical 2. And then we have pi. Pi is 3.14. Between what numbers do we find pi? Which numbers? If you want to put this on the number line, where would you put it?
You want pi number 9? You would put it between 3 and 4.
Between 3 and 4, that's right, because 3 and some change. Is it closer to the 3 or closer to the 4?
Definitely closer to the 3.
That's right, so 3 and 4. So 3.1 is right over here, 0.1, 0.2, 0.3, and so on all the way to 4. So very close to 3. That's where you find the pi, 3.40. And of course, the other number, 3 to the second, which is 9, will be somewhere over here down the line. Okay, so that's what I mean by the number line. All the real numbers could be put on this number line. And now let's compare some numbers, some real numbers. The comparison, when we compare real numbers, meaning we just say which number is higher than what. We compare 2, for example, we compare 2 and 5, and we can compare also 4 and 1. We use comparison signs. We use either less than or greater than. So 2 compared to 5 is 2. Which symbol do you use from here? So less than. This is greater than. Which one do we use for 2 and 5? 2 is, of course, less than 5. 4 is greater than 1. So no big deal with positive numbers, but it gets a little tricky with the negatives. For example, if you want to compare -1 to -4. -1 is here, -4 is here. What is the comparison here? -1 is what compared to -4? Which one is it of these two?
To the right.
Which one is it? Is it this one or that one? What is the
Actual one is greater.
-1 is greater. That's right. So -1 is on the right, -4 is on the left. So any number that's on the right, it's higher than any number that's on the left. We compare two numbers to look at them. So -1 is higher than this. Same way 5 is higher than 4, higher than 3, higher than all these. So -1 is actually greater than -4. This is not 1 and 4. This is -1 and -4. What about -3 and -2? What is -3 compared to -2? Is it this or this?
2 is greater. -2 is greater.
Okay, that's good, but we need to read it from left to right. So what do we say about -3 compared to this? -3 is? So we read it from the left, would be?
Less than.
Exactly, less than. Okay, so same way, 100 compared to -1. Don't let the numbers fool you. We have a negative here, so -100 is?
Less than.
Exactly, less than. So -1 is here, -100 would be down or way over here. It's much, much smaller than -1. In other words, you would rather have -1 balance in your account than to have a -100. Here you owe too much. That's much worse than owing, for example, $1. Okay, so think about the number line when you compare negative numbers. Whichever number is on the right is higher than the number on the left. What about 0? What about -4 compared to 0? 0 is here. What is the comparison here? Everybody, -4 compared
less
to
than
0.
0.
I'm sorry, say it again.
4 is less than 0.
Less than. That's right. So 0 is actually better than all these numbers. In other words, 0 is greater than any negative number because 0 is on the right of all of them. So that's the comparison there. Okay, let's see what else. So The number line pretty much summarizes all, or presents all, represents all the numbers, all the real numbers. And with that, we can do a lot of things, including basically comparing the numbers. We can also plot the numbers on that number line. We can do a bunch of things. Now, one other property of real numbers is we call the additive inverse. What this means is simply that 0 is here. It simply means that any number on the right has an opposite number on the left. For example, the opposite of 3 here would be what's the opposite of 3 on the other side of the 0? Could be simply this number with the opposite sign. Okay, so we say these two are opposites, -3 and +3. So we can say the, and when you combine, so we say the opposite of 3 here, so we say the opposite of 3 is -3. So the opposite of 3 is -3. You read this negative as the opposite. The opposite of 3 is -3. Of 3 is -3. Now, what about this one? What is the, let's say you have -4 here. What is the opposite of -4?
-4 or 4, I mean.
Will be 4, right? Will be
4, yeah, I'm sorry.
right. So just
I'm looking at what you wrote and stuff, and it's like opposite of -3 is 3, but it's just the of.
oh, that's right. So when you say, for example, -3, the opposite of -4 is 4. We can write it this way. We say the opposite of -4. So the first negative we can read as the opposite of -4, which is +4. Basically, it's this one. Or when you say the opposite of 3 is -3. So this is what the notion of the double negative comes from. So basically, we have double negative, which turns into a positive. This one is just one negative, so the opposite of 3 is -3, but the opposite of -4 is +4. So double negative. Or first, let's write the whole thing. The opposite of -4 is +4. Double negative turns into a positive, in other words. Okay, so so whenever you see two negatives like this, one parentheses and another negative, you can immediately turn that into a positive like this. That's important. So that's what we mean by the additive inverse. It also means that whenever you take a number and its opposite, for example, 3, the opposite of 3 is -3. So the opposite of 3 is -3. If you take those two together, of course, they cancel each other out. You get 0. So the opposite of 3 is -3. These cancel out, you get 0. Same thing here. The opposite of -4 is +4. If you write those two together, what is -4 plus 4? They also cancel each other out, okay? Because the same number of signs. This is what we mean the additive inverse, is when we combine a number and its opposite. A number and its opposite, it's always going to be 0. -7, for example, the opposite of -7 is +7. The result is 0. So that's what we mean by the additive inverse property. Another property, number 5, is called the absolute value. The absolute value of a number. The symbol is this, 2 vertical bars like that. So this we read as the absolute value for whatever is inside. So, for example, something like this. So we say the absolute value of -3. Does anybody know what the absolute value of -3 is? What is this equal to?
3.
That's right, 3, or we can say +3, same thing. Okay, so basically the absolute value makes the number positive. It just gets rid of the negative sign. So we say the absolute value of what's inside -3 is +3 or just 3. And what if the number here is already positive? What do you think the absolute value of the number would be? Let's say we had 5 here. What is the absolute value of 5? So in this case, it's already positive, so that stays positive. Okay, that stays positive like that, because it's already positive. It does not reverse the sign every time. Only when it's negative, it turns it positive. If it's positive, it remains positive. Do not confuse this with the opposite or the additive inverse. Additive inverse, that's when we flip the sign. 4 becomes -4, or -3 becomes +3. But absolute value always has a positive value, or it can even be 0. For example, -2 here, you can get 0. Okay, so it can never be negative. So the absolute value of +5 is 5. Okay, as you can see, the outcome is either positive or negative. So let's write that here. So the absolute value is either positive or 0. Okay, it cannot be negative. That's very important to remember. Do not confuse this with the opposite or the additive inverse. Okay, so now let's do some more examples here. Sometimes you may have more than just one number. You could have 3, and inside maybe something like this, and maybe that as well, something like that. So just like the order of operations, you may see multiple operations and numbers with the absolute value. So let's try to evaluate this, simplify it. Where do you think we start from with this expression? Anybody want to take a guess? Where do we start from? Okay, just like the order of operations, when you evaluate these, we also start inside as if these were parentheses. They're not parentheses, but we do follow the same order as them does. These basically have priority, either parentheses, if you have them, absolute value, or brackets. All these pretty much have the same priority over the other operations. So you would start from the inside here. So you will do 6 or 8, take away 6, 2, then bring the 3 down, bring the -4, and continue. Now, what is the absolute value of 2? We have 2 inside. What is the absolute value of it according to this?
I want to say -2. No, or just regular 2, or just minus, I guess.
If the number is already positive, see, like 5, the number is positive, it remains positive, okay? Only change the sign if it's a negative, so when it turns into a positive. So these 2 is already positive, just like 5. So the absolute value of 2 is?
2.
That's
Positive.
right. 2, positive 2. We have 3 times whatever this is, so it's going to be 3 times.
2, so you'll get 6 minus 4.
That's right. So now we're going to do 6, take away 4, finally 2. Okay, so same order as the PEMDAS order of the parentheses. It's also possible to have, let's say, so 5, absolute value of negative, let's say 4, and plus 1. Same way, what do we evaluate first? Where do we start from again? Same as this.
You're going to change the -4 and the absolute value to +4.
Exactly. So the negative turns into 4.
And then you're going to multiply 5 times 4, you'll get 20.
Okay.
21. Simple.
That's right. So this turns into a multiplication. 20 plus 1, we get 21. That's the answer. So very similar to the order of operations with parentheses. But remember, positive stays a positive, negative turns into a positive. Do not confuse that with the additive inverse. Again, that's when you do the opposites. The opposites always have opposite signs. That's pretty much the property of absolute value, additive inverse, and real numbers. Now let's switch to, let's see, we're going to learn the signs of addition, subtraction, multiplication, and division of these numbers. Okay, the signs are very important. And we're going to do that based on the number line. We're going to see how to do something like -2 -1, for example. As I mentioned in the previous lectures, we would do a detailed class on the signs, and that's what we're going to do now. So this will be the other section, 1.4, 1.5. Let me bring that over here. All right, so as you can see here, you're going to learn another couple of units from the book. So we're going to see addition, subtraction, multiplication, and division of real numbers. So now that we know what real numbers are, what they're made of, and we saw a couple of properties, we're going to see all the rules of the signs of real numbers, or what we call signed numbers. Also call them signed numbers because the negative could be anywhere, and sometimes we combine 2 negatives or 2 positives. So let's see how to do that on the number line. So that would be 1.4. Okay, let's start maybe with addition and subtraction. Going to do addition and subtraction, and later we'll do multiplication and division. To do that, we're going to need the number line again. We can clearly see the numbers and the signs when we use the number line. So again, it's 0 in the middle. You have 1, 2, 3, 4, 5. On the other side, we have -1, -2, -3, -4. And so on. So we're all familiar with, let's say 2 plus, or 3 plus 2, for example, 3 plus 2. So we all know that's 5. If you look at it on the number line, so you start from 3, then you go 2 units to the right, because it's positive. Addition, we go to the right. So we start from 3, we go 2 units, 1, 2, we end on 5. Same thing with, this typical subtraction. So we start from 3, then we go, since it's negative, we go to the left. Start from 3, go to the left 2 units. So 1, 2, we end on 1. That's why we say 3 minus 2 is 1, 3 plus 2 is 5. Okay, that's pretty much what we know so far. It's obvious, right? We don't have a problem with this. But we do get into some issues when you have something like this. -1 plus, let's say, 4. Okay, that's when it gets a little tricky. So what do you think -1 plus 4 is?
+3.
+3. Okay. How did you come up with that number, with that answer?
I mean, I really use mental math, but if you wanted to do it the long way, you would have to.
Did you use think about the number line? You just knew the answer.
Yeah, I mean, you could look at it and get the answer, but if using the number line, you would start off at 4, +4.
Mm-hmm.
-1 would bring you left 1 time, and which would bring you to +3.
Okay, that's one way to look at it. So you can either just do it because you know the rule, or so basically you would start from here. Always start from the first number and either go left or right based on the sign as many times as this. So we start from -1 in this case, then we go to the right 4 units. So start from -1, we go to the right 1, 2, 3, and 4. So we get to +3. And what about -2 minus 1? You can either do it with a number line, or you can just think of it the way you think of it usually or normally. So what is -2 minus 1? Other people in the room, Maria, Stella, and Troy, everybody else, because it's a free country. You can engage, you can ask questions, respond to questions.
-2 minus
We need to know whether you're on board, you have questions or something. Please engage. Participation is important, and it's part of your grade. You not only learn things, but you learn how to communicate and how to engage, and you will definitely pay off and earn new points. Okay, up to 10 to 15 points of the grade is based on participation. Please feel free to ask your questions and answer them. Go ahead, Gavin. Gavin, what was that again?
Sorry for trying to talk over you, Professor. I got cut off. But so you got -2 minus 1, so you'll just keep change. So you'll rewrite the problem to -2 plus -1.
Okay.
And you'll get -3.
All right, you can do that. You can think of it as turning it into an addition, or you can also simply start from here. We have a negative here, so we go to the left once. Start from this number, which is here, and then we go to the left once. Because it's a negative, you go to the left. If it's a positive, you go to the right. You go exactly once. So start from -2, go to the left once, you get -3. So if you ever get confused with the signs, you can simply make a small number line here, and you can get your answers, or you can be sure about your answer by using the number line. So that's basically, these are obvious. We don't have a problem with these, the first two, but these can be confusing. Trust me, even in college algebra now, I see people making mistakes and confusing the signs all the time. But once you understand the concept of, especially with these two, you will never get the signs wrong. And knowing the signs in math is very, very important. So now the numbers are not always this small, so we can put them on the number line. What if we have 100 and 200? What if you have your negative 300 minus 400? It's not always convenient to draw a long line with all the numbers. So let's conclude some rules based on this and use those rules, apply them to larger numbers. So if you look closely here, we have a negative and a positive. And the sign that dominated, or the sign that won, is the sign of the higher number. So we pick the sign of the higher number. At the same time, we basically do the difference of those numbers, the difference of those values. You have 4 and 1, the difference of those is 3. But when we have the same sign, as you can see, we keep that sign, we basically add the two numbers, we combine them. So here, pick the sign of the higher number, then pretty much subtract. By that, we mean subtract the smaller number from the higher to get 3. But if you have the same sign, basically keep the sign and add. So pick the higher sign and subtract, keep the same sign and add. So even if you had, let's say positive 500 minus, let's say 600. Again, we don't want to use the long number line, so let's apply the same rule here. What would this be equal to? Which sign do we pick? Do we pick first out of these? Pick the sign of the higher one, which would be the higher number. That would be a minus. And then we do the difference. So different signs we need to subtract. So if you subtract 600 and 500, the result is 100. Okay, that's when the signs are different. What if the signs are the same again? We keep the sign and we add the two values. Let's say we have negative 300 minus 400. What is this equal to? Same idea as here, without the number line this time. What is the answer here to this operation? Anybody want to try? Okay, we do exactly what we did here. So just apply the same concept to this. And what is the answer here? Without thinking of a long number line. Let's start with a smaller example. Again, what is negative 3 minus, let's say, 4? What is that equal to? If you do it the same way. Everybody, what is this equal to?
You're asking for negative 3 minus 4?
Mm-hmm.
For negative 3 plus negative 7?
Negative 7. Again, we just keep the sign, add the numbers. Apply the same rule to this. What do we get?
Negative 700.
That's right, same thing. So regardless of the values, so keep the same sign and add the values. Here, if you have different signs, we do the difference. Difference meaning subtract. So different signs do the difference, same sign, add. So let's write those rules here. So we can say same sign or different signs here. So different signs. Keep the higher sign and add and subtract. And over here, number 2, basically same sign here. So we keep that sign. And add the values. So these are the only two rules that you need to remember for addition and subtraction, and you will never get the signs wrong again. Very simple. So if you have different signs, you gotta keep higher and subtract. If it's the same sign, you gotta keep sign and add. Keep that same sign and basically add. Okay, you will never get anything wrong after this. I mean, if you apply these two rules. Okay, so let's say, okay, we'll get back later into some, we get some practice with when we combine both multiple of these things together. So multiple of operations together. So that's number one and number two. Again, this only applies to addition and subtraction. Do not apply this, or do not apply this to multiplication and division. It's a little different. Okay, so number two now, we're going to do multiplication and division. They're also quite similar, pretty similar to, they're pretty much the same rules here. So we have two rules here. These two also are quite similar. We're going to do two rules of them. Two rules for addition and, for multiplication and division. First of all, when we talk about multiplication, let's do multiplication first. When you multiply, we have multiple ways of writing multiplication. We can say A times B, for example. A and B are real numbers, meaning negative, positive, decimals, whatever. You can say it this way. You can also say A parentheses B. Could also be like this. Just one of them is in parentheses, or they could be both in parentheses. It's even possible to just put a dot in between. That also means a multiplication. And finally, you could, if you want, you don't have to put anything at all when you have variables like this, letters. A, B means A times B. So all of these pretty much mean the same thing. They mean multiplication. Let's do a few examples. So the rules here, there's only a couple of rules, just like this. So we have these rules that we all know. So we have one. So we all know that when you times positive and a negative, the result will always be positive times a negative. The result is always negative. Okay, all know that. The other rule is you multiply two negatives. So negative times a negative. That's always going to be negative times a negative is
Negative.
this.
I'm so sorry. No, I'm so sorry. I'm dumb. Should be positive, right?
Positive, right? It's always going to be positive.
I apologize, sir.
That's all right. I know you probably got confused with this. So if you have two negatives here, the reason why it didn't turn into a positive is because this is not a multiplication or division. This is a subtraction. So the negative stays a negative. When the negative turns into a negative, that's when you multiply or divide. So negative times a negative is always positive. Also, when you multiply different signs, in other words, when you multiply different signs, always negative. When you multiply same signs, always positive. These are the rules of multiplications. There are also the same rules apply to division. But let's do some examples first with multiplication. and later we'll do some division in these forms, for example. So let's say -2 times. Okay, here's a simple one. -2 times 3, that would be the sign is, so it's like this,
6.
6. What about 3 and something like this? So multiply here. Negative.
-12.
That's right. And it may also be something like this, -1, parentheses, -2.
That gives you negative. I mean, I'm sorry, +2, because it's two negatives.
Positive 2. So any one of these forms, basically, and just remember, same sign positive, different signs negative. And this is again talking about multiplication and division, not addition and subtraction. These
Gotcha.
are a little bit different. All right, so that's multiplication. Let's talk about division. So division can also express in a couple of ways. Unlike multiplication, we have a variety of ways to write it. Division, we have about at least 3. So we can say A divided by B. That's the common one. That's the division sign. Or we can say A by B. Most calculators have this forward slash for division instead of the division sign. I mean, the computer keyboards have forward slash for division. Or we can also express division as a fraction. So A over B. This is A by B. A over B. This is A divided by B. I don't think there are, at least, I don't think there are any other ways to write divisions. So these are the common ones. In any form, they basically mean the same thing. But the rules are the same. They have the exact same rules here. By that we mean when you divide different signs, divide positive or negative, just like a multiplication, this will is going to be negative. And also, the rule number 2 is if you divide two negatives, it's just like multiplying two negatives. So negative divide. What is a negative divide a negative? Will be
Positive.
That's right. Just like multiplication, it's positive.
Gotcha.
These, right? So these share the same rules. So to sum this up, I know we probably seen before 8 rules or this or that. Forget about that. You just need to remember 2 here and 2 for multiplication and division. That's it. When you multiply or divide the same signs, whether they're negative or positive, it's going to be positive. If you multiply or divide in different signs, the result always negative. With multiplication and division, we don't care about the values of the numbers. We just look at the sign. But when we do addition and subtraction, that's when we do look at the values of the number. If the number is higher, okay, we pick the sign of the higher number here. If the signs are the same, it stays the same, basically. It doesn't change. So there's all the signs here. And let's do a few examples here for a division. So again, division could be expressed like this. So you may say 15 divided by -3. Okay, so always try to break this down into 2 steps. Get the sign first. That's very important that you get the sign right. Once you get the sign, then you get the value. You get the value by dividing or adding or subtracting, whatever the operation might be. First, let's get the sign. What is the sign here of the quotient of the result?
Negative.
That's right. And then you perform the operation, which is
5.
value would be 5. It may also be, let's say, -21 divide or by 7, for example. What is the answer here?
-3.
That's right, -3. You get your sign, then you get your value. You may also have, let's say, 18, -18 divided by -6. So division, negative divided negative is
Give you a +3.
positive.
I'm sorry. Yeah, positive. I'm tripping. So always negative in division will give you a positive.
That's right, always.
Okay.
Just like multiplication. So they have the same rule.
Gotcha.
All right, so we may also see -6, let's say, divide -2. This would be
+3.
exactly. Okay, so that's your guide to signs. Signs are very important in math. Again, they're involved everywhere. And they,
Important method, but easily mistakable.
yeah, you can easily make a mistake. And if you make one, if one sign is wrong, your whole expression or equation or problem could be wrong. So they do require concentration when you do them. But hopefully with this, you guys should never have a problem with them. And I see people still struggle. Like I said, in my college algebra class, they still confuse the signs. They don't know what to do. Does it turn positive or negative? And once you know the signs, everything else makes sense. So hopefully that clarifies it. Now, let's mix everything up now. We're going to mix all these together in an order of operations and do some problems, mixed problems. So we can call this number 3. It's order operations and signed numbers. There's another name for these are signed numbers because you can see these negatives everywhere, this and that. We call them signed numbers. So we can let's say this plus 1. Okay, so we saw this earlier. What is the opposite of -3? Or what's -3? This turns into
+3 plus 1.
that's right. This is a double negative. Turns into +3. Bring down the other number, and that's 4. You may also see, say, -5 minus plus, let's say, 2. Whenever you see parentheses and a minus in front of them, think of it as the opposite of something. So the opposite of -3 is +3. Here you want to turn this, you want to clear this first. What is the opposite of +2?
So it would be -2.
That's right, -2. Bring down the -5.
And then you change, and it would give you -7.
Exactly, -7. Keep the sign and add the two values. You may also see some parentheses. Let's say probably -3, and then you have 7 take away 5 to the second power, and plus maybe 11.
All right, well, first off, you got to start off with the parentheses, and that would give you 2 in the parentheses.
Okay.
You would have to take care of the exponents, so that would give you 4, and then it would give you the -3 outside of the parentheses, which would give you -12 plus 11, and then that would give you -1.
Correct. Very good. So always the parentheses first, so that turns into a 2. We keep everything else the same. Then the exponent before the multiplication, that's 4. We have -3 here plus 11. Finally, the multiplication, that's -12 plus 11. And what is the final result here for -12 plus 11?
-1.
That's right, -1. So you pick the sign of the higher number, negative, and then the difference. So they have different signs. We do the difference, meaning the subtraction. What else? Let's see. So we have say 6. We want to divide that by say -1 minus 2, and multiply this by maybe 4, or possibly -4. Okay, so no reason to be scared of the minuses now. We know the rules. We can navigate our way through any sort of operation, minuses or no minuses. We know how to deal with this.
Yeah, for sure. So the first stuff, you're gonna start off with the first parentheses, and that would,
Start from here.
yeah, and that would give you -3.
Very good. So -1 minus 3.
And then you would just work from left to right, and you would get -2
Okay.
times -4,
Okay.
and that would give you +8.
Very good. That's right. So we did the parentheses. Then we had division and multiplication. As we saw last time with the order of operations, we do that left to right. So left, then the right. That's why we did this first. Positive divided to negative is negative. You brought this down. Finally, negative times a negative is +8. And that's pretty much how you handle this. So
Pretty simple.
any type of signs, any numbers, order of operations,